Okay, let's move on to year end review number 4 now, and let's talk about our angle properties. So here we have two lines, and these lines are parallel to each other. And this line, the diagonal line that crosses them, is referred to as the transversal. So when we have a transversal cutting two parallel lines, we get 8 different angles that are created. Now, these different angles all have different types of relationships, okay? Some are called corresponding, some are called alternate interior, some are called alternate exterior, and actually I forgot about opposite angles. So I just want to go through and list them for you. So opposite angles would be like 3 and 4. It would be 1 and 8. It would be 6 and 7. And it would be 2 and 5. Now, all of these are equal to each other. So if you know the measure of angle 3, you automatically know the measure of angle number 4. Okay, just erase that. So next up we have is corresponding angles. So corresponding angles, these angles have to appear on the same side of the transversal, but one of them is from the top 4 and one of them is from the bottom 4. And again, these angles are going to be equal to each other. So for example, if I start with number 4, so number 4 is going to be the same as number 7. So 4 and 7 are going to be equal to each other, and their relationship is called corresponding. So another set would be 8 and 5. Another set would be 1 and 2. And the last pair of correspondings would be 3 and 6. Okay, and again, if you know the measure of angle 3, then you automatically know the measure of angle 6 because they are equal to each other and they are corresponding angles. Okay, the next one we have is alternate interior. So alternate interior, so first off, the interior angles are the angles that appear on the inside of the transversal. So the alternate interiors are 7, 2, 8, and 3. Those are the 4 interior angles. Now, again, these ones are equal to each other. Now, what's different is with corresponding angles, they both have to be on the left or they both have to be on the right. Whereas alternate interior, we want one of them on the left and one of them on the right. So 8 and 2 are alternate interior, and 3 and 7 are alternate interior. Now, sometimes alternate interior angles are called the Z angles because if we create a Z, then we've got the 2 angles here. Same way here. If I create somewhat of a Z, then this one and this one are equal. Okay? Alternate exterior, exact same idea, except with alternate exterior, instead of using the inside angles, we have to use the outside angles. But just like the others, they are also going to be equal to each other. So angle 4 is on the left, angle 6 is on the right, so 4 and 6 are equal to each other. And then angle 1 goes with angle 5. Okay? Now, another set of angles that I didn't write on here, but it's quite common, we've used it actually in other applications, is the idea of supplementary angles. Supplementary angles are angles that create a straight line. So here I have a straight line. So angle 6 and angle 2 are considered supplementary. Now they are not equal to each other, but they add up to 180 degrees because there's 180 degrees in a straight line. So here's another straight line. So angle 1 and angle 4 are considered supplementary. So supplementary angles are not equal, but they do add up to 180 degrees. Now, not all angles are considered equal. Same side interior does come up every now and then. Same side interior, so same side means they're both on the left or they're both on the right. Interior means they're on the inside. So this would be 3 and 2. So 3 and 2 are considered same side interior, but these are not equal to each other. These ones add up to 180. So the other ones, 7 and 8, are considered same side interior. Again, they're not equal to each other, but they do add up to 180 degrees. Okay, so those are all of our different types of angles, and we can use those relationships to help us find missing values. So for example here, it says, are these lines parallel? So there's lots of different ways to explain, but you are asked to explain. So there's many, many, many different ways you can explain this. So what I would probably do here with this is I'd probably go like this. I'd say, okay, if this is 146, that means this one's 146 because they're corresponding. Now, if these two lines are then equal, then what I now have here is I have a straight line, which means that this plus this should equal 180 degrees. And it doesn't. So they're not parallel. Now, that is not the only way you could describe this. You could describe this in countless ways. Another way that you could describe this is you could say, okay, if that's 146, then that's 146. They're opposite. Now, these are same side interior. So again, they should add up to 180 degrees, but they don't. So that's another way you could describe it. But there's really no set way, but you just have to, just giving an answer of yes or no is not enough. You have to describe it somehow using the words from the last slide. Okay, we did some rules with triangles. So the rule number one is the angles of a triangle have to add up to 180. You know that one. We've used it lots in trig. A new rule was that if you know the measure of these two inside, they will add up and give you the measure of this angle that's on the outside. Now that one's just kind of handy to know every now and then, but it's not an absolute ride or die kind of rule. So let's use some examples here. So again, what these arrows here mean, it means that this line here and this line here, they are parallel to each other, which means then that this line that's crossing them, that is the transversal. Okay? So what I would first do is I would see that this is 30 degrees and I would make my Z. See, I've got a Z there. So if this is 30, that means that that one is 30. That's the alternate interior angles. Now, once I know that, then what I would do is I would see that I have a triangle here. I know two of my three corners, so now I can find D. So I can go 180 minus 65 minus 30. And so that gives me out 180 minus 65 minus 30. That gives me out 85 degrees. Okay, so we use these angle properties to help us find missing angle measures. Okay, so here's another one. So PQRST, that's what we're looking for. Now you can do this in any order. You don't have to go in the order of the letters, and sometimes you can't go in the order of the letters. Sometimes you have to find the letters out of order because of just how you're going through the question. So I would start off here. I have a straight line. So I know that these two right here have to add up to 180. So I'm going to go 180 minus 111. So I know this corner right here is 69 degrees. I'm going to use that exact same reasoning right here. I have another straight line. So I know that this is 128. So I know that this one and this one have to give me 180 degrees. So if I go 180 minus 128, I get 52 degrees. Now what I see right here, I see a triangle. I know two of the three corners. So for R, I can go 180 minus that 69 minus the 52. And I get out 59 degrees. Now again, back to those straight lines. See right here I have a straight line? So I know this and this are supplementary, or in other words, they have to add up to 180 degrees. So if I go 180 minus 59, I get out 121 degrees. Okay. Now, a couple different ways you can do this last one, finding letter T. What I would do, again, I have a straight line here. So I've got 71 here, so I know what that is. So I can go 180 minus 71. is 109. Now, the other way that you could do it is you could say, hey, I've got these 4 angles. They create a circle, right? Well, how many angles are in a circle? 360 degrees. So I would minus off the 71, minus off the 59, minus off the 121, and I would still get out 109 degrees. Again, lots of different ways to do this. If you would have attacked that question completely differently, but your answers are matching mine, you keep on doing you, right? You're 100% allowed to slice and dice these things any way that you need to. Okay, we did look at polygons. So remember, a polygon is just any sided closed shape, okay? So there's a couple formulas. You don't have to have them memorized. We give them to you. So it says the sum of the measures of the interior angles. So what that means is that if I were to add up all the corners on the inside of the shape, I could find the total sum of them by going 180 times n minus 2. N is the number of sides. Now, if I wanted to find the measure of each one of those corners, I would go 180 times n minus 2, but then I would divide my answer by n. Now, the last one is the exterior angles formula. That just says that if you add up all the exterior angles of a polygon, it would add up to 360. We don't really ever use this one too much, so we're not going to spend really any time on that. So let's go on to look at these 2 questions. So it says, how many sides does a polygon have if each of its interior angles measures 170 degrees? So I've got 170 degrees equals 180 times n minus 2 divided by n. And you're looking for the number of sides. Now, you could do this algebraically, but really quite often, it's just the easiest way to do it is by guess and check. So what we're going to do is we're going to put random numbers in for n until we get out 170. So I'm going to start with 5, and let's see if that works. So I'm using my calculator. So I'm going to go 180 times 5 minus 2, and then I'm going to go divide by 5. And I get out 108, and I'm trying to get out 170. So let's try 6 now. So I'm going to go 180 times 6 minus 2, 6 minus 2 divided by 6. 120, so I'm getting closer. Okay, let's try 9. So 180 times 9 minus 2 divided by 9. 140, oh, getting closer to 170 all the time. So let's try 180 times 12 minus 2 divided by 12. Oh, still not there. Getting closer though. Let's try 18. Nope. Let's try 22. A 22-sided shape. I have no idea what that's called. Nope. But we're getting closer. Let's try 30-sided shape. Oh, so close. Let's try a 34-sided shape. Very close. Let's try 35, or let's try 36-sided shape. Whoops, divide by 36. And there it is. It is a 36-sided shape. Okay, so even though it does take a little while guessing and checking, it's just, honestly, it's the easiest way to go about those questions. So I have no idea what a 36-sided shape would look like, but I'm sure they exist. Okay, let's try this question. So it says, determine the value of y. So what I would do here, what would I do here? Okay, so I'm going to start on this triangle right here. So I know 2 of the corners, so I can find this third one. So I would go 180 minus 33 minus 42. And I get out 105 degrees. So this is 105. Now I see I have a straight line here. So this would be 180 minus 105. So that's 75 degrees. So now what I have is I have this polygon. I have this random shape. So first off, how many sides does it have? Well, 1, 2, 3, 4, 5. So the sum of the angles has to be 180 times 5 minus 2. So if I plug that into my calculator, I get out 540 degrees. So now this is where we do have a little algebra involved. So we've got y plus y plus y plus 75 plus 135. So those are all my corners. And that has to give me out 540 degrees. Okay? So y plus y plus y is 3y. 75 plus 135 is 210 equals 540. So I'm going to minus 210 from both sides. So 540 minus 210, and I get out 330. I'm going to divide both sides by 3, so y equals 110. Okay, so again, using a little bit of our angle properties with a little bit of some algebra skills. Okay. Okay, the last thing we did in this unit was congruency. So if you remember, congruent means two shapes are identical. They're the same size, the same shape, all the side lengths are the same number, all the corners are the same number, everything matches. So there's three ways we can prove congruency. And the first way is called SSS, or in other words, side, side, side. So if I know that this side and this side are the same number, I know this side and this side are the same number, and I know this side and this side are the same number. If I've got three matching sides, then I can assume that the three angles will also match, and it's called side, side, side. SAS means side, angle, side. Now the catch is the angle must be between the two sides. So if I know this side right here, and I know this side right here, and let's say I know this side right here, and I know this side right here. If I know this angle right here, and this angle right here, so side, angle, side, side, angle, side, then I can say that those two triangles are congruent. Now, just to compare this here, if I gave you this, side, side, and that angle, that is not side, angle, side, because the angle is not between the two sides. Okay, so the angle has to be between the two sides in order for it to be side, angle, side. And then the last one is angle, side, angle. So again, you probably can assume here that the side has to be between the two angles. So let's say I know this angle here and this angle here. Let's say I know this angle here and this angle here. That must mean then that I know this side here and this side here. So again, if I have that set up, if I know that those two angles and that side between them are matching, I can then assume that everything else will also match. So what do questions look like on this? So it says, if we say that triangle AFS, now this little symbol here means congruent. So it says triangle AFX is congruent to triangle HJR, then we know that. Okay, so very, 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 very important. The order of those letters is absolutely crucial. So if I have my two triangles, label the first one in any order that you want. But when you're labeling A is going to be congruent to H. So whatever symbol you use for A, we have to use the same symbol for H. Whatever symbol I use for F, I have to use that same symbol for J. And whatever symbol I use for S, I have to use that same symbol for R. Okay? So which are the angles that are congruent? So angle A is congruent to angle H. Angle F is congruent to angle J. and angle S is congruent to angle R. What sides are congruent? Okay, so side AF, so again, this one is across from the X, so across from the X is side HJ. Okay, across from the closed circle is FS, across from the closed circle is JR. And then finally, across from the open circle is AS, and across from the open circle is HR. Okay, so for example, if I were to tell you this number here is 7, then you would automatically know that whatever is across from this is also going to be 7. Now, typically when they do these questions, they will have this triangle looking like this, but maybe this one, they rotate it around. So they'll have R, H, J like that. So then you'll have to, again, kind of come up with your matches and knowing it. So you know that A and H match. So A and H match, okay? So F matches with J, and then R matches with S. So if I know the one across from here is 7, then a 1 across from here will also be 7. Okay, so again, it's figuring out those matches, and the matches are found by following the order to which the letters are written. And as long as you follow that order, it will work for you every single time. Okay, so that concludes our angle properties review. So again, try the questions in the assignment. If you get stuck, feel free to ask.